The call stack contains a frame for the call split B, with B containing a pointer to the array containing 5 ones. We execute the call that is in the body of split. A frame for the call is placed on the call stack, and the argument values are stored in the parameters. In the frame for the call, we show parameters k, s1, and s2. We don't show b. It's a pointer to the array with 5 ones. Now execute the body of split. Start with the if statement. Since k is 0 and b.length is 5, execution of the if statement terminates. Next, execute the return statement. We evaluate the first call on split, putting a frame for the call on the call stack. In the new frame, k is 1, which means that b sub 0 has been placed in the bag. Parameter s1 is 1, indicating that b sub 0 has been placed in the first bag. The second bag is still empty. Next, execute the body of split. This works as before. The if statement has no effect, and the return statement is executed, causing another frame for the call to be placed on the call stack. This time, k is 2, and the first bag contains 2 values. In fact, we can see that this will happen 3 more times until k in the top frame is 5. All 5 values have been placed in the first bag. At this point, k equal 5 in the frame for the call, so k equal b.length, and the if condition of the if statement in the body of split is true. Parameter s1 is not equal to s2, so the frame for the call is popped and false is returned. This is the first example of backtracking. A choice was made when k was 4, and it didn't work. So, the second choice, putting bk into the second bag, is tried. We make the frame where k is 4 red to indicate that the second call on split in the return statement is being executed. Again, at this point, k equal b.length. The frame for the call is popped, and the value of s1 equal s2 is returned. It is again false. Backtracking occurs in order to attempt a different choice. But this time, it is the second call on split that returned false. So the frame for the call is popped, and the value of s1 equal s2 is returned. Again, it is false. More backtracking. Eventually, the call split b110 will return false. This will cause the second call on split to be executed, with the first 1 being put in the second bag. Now a lot more calls and backtracking will take place before the call split b000 returns false. We modified function split to also calculate how many calls on split are made. See our revised method in the demo code that accompanies entry backtracking in Java Hypertext. When the values in array B of size n cannot be split into 2 bags so that their sums are the same, 2 to the power n plus 1 calls are made. That's exponential. That's huge. Thus, split takes time, order 2 to the power n in the worst case. We could have predicted this. Each value can be placed in bag 1 or bag 2. There are 2 to the power n sequences of 1s and 2s of length n, and each has to be tested by split.